Okay, so what we're going to do now is we're going to look at the domain if I take two existing functions that I know of, like probably ones from your parent functions, and we put them together. So today we're going to talk about combining function. Tomorrow we're going to talk about composing function, and they're different. Combining function is like this. Let's say, for example, you have a function f of x, and we're going to combine it with another function, g of x. So f of x has its allowed domain. G of x has its allowed domain. When we add them together or we combine them together, what we're going to do is we're going to look at their intersected domain. So this is the combined domain. So if we have two functions, f of x and g of x, where the domain for each of the functions overlap means that there's some here, that's some there, they are the same kind of domains, then we can do the following algebraic combinations. So sum means that we can add f of x and g of x together. So if the domains for each function overlaps, then we can add them together, and that's okay. We can subtract them if we want. So either this way or this way. We can multiply the two functions together. And then we can also divide them. So we can take f divided by g. We just have to make sure that g of x is not 0. Or we can take g of x divided by f of x, and we just have to make sure f of x is not 0. Okay, so we are combining functions. When we mean combining, we mean put them together in the algebraic combination. Adding, subtracting, multiplying, dividing. That's it. That's the only things we can do to combine them. Okay, so for example, we have two functions. F of x is x squared. G of x is square root x plus 1. What we're going to do is we're going to combine them together in with algebraic methods. The problem is we have to check the domain because not everything that passes through one will be allowed in the other. So, okay, we'll look at that last. Okay, so let's look at f of x. What is the domain of f of x? F of x is x squared. What's the domain of f of x? All real numbers. So negative infinity to infinity. What is the domain of g of x? G of x is square root x plus 1. What's the domain? Greater than or equal to negative 1. So negative 1 to infinity. All right. So now what we're going to do is we're going to add f and g together. F is x squared. G is square root x plus 1. And we're just going to add them together. Now, if you look at this final function, and then I ask you, what is the domain? You may be a little bit scared because you're like, oh my gosh, that looks very hard to figure out. So what we can do is just look at them separately. So this is the case of the picky eater. So for example, let's say that one day, Aaron and I decided to go eat after school. And then let's say that Aaron is a very nice person and he says, everything is okay with me, I can eat everything. But then I am trying to watch my weight, and then so I said, oh, I can only eat things that's low calorie. So then if we go out to eat together, what kind of food will we have? Can we have In-N-Out? Probably not, that's high calorie. That's like 600 calories per burger.
So specific. How did you know that?
Oh, they posted on the menu. What else? Can we go eat like boba?
No.
No, that's very high calorie. So what kind of things can we eat?
What calorie?
Low calorie food, are there such places? Huh? Salad, supplementation? What? Snacks. I guess. That's like 200 calories per bag. So basically Aaron says he can eat everything. I say I can only eat low calorie foods. So who's the picky eater? I am, right? So then when we go out to eat, you have to go with my preference, right? So it's the same thing with the two functions. F of x and g of x decide to go out to eat, and then f of x says I can eat everything. G of x says no, only -1 and higher. So what kind of things are they going to eat? Yes, -1 and higher. So you take the picky eater. Okay? So this is the case of the picky eater. All right, so no matter what we do, we are looking for the picky eater. Okay, so f minus g is the same idea, x squared minus square root of x plus 1. So what's the domain? Not 1. -1 to infinity. So same thing, right? We didn't change anything. F times g. Same thing, yes. Next one, f divided by g. This one's a little bit weird. X squared divided by square root x plus 1. So this is the case of, let's say Aaron and I decided to go out to eat. And then all of a sudden, let's say that we got into a car accident. And then all of a sudden, not only can I not eat low-calorie foods, I also have to eat pills. Okay, to take some medicine. So then we have to take more things out because something bad happened. Okay, so in this case, f divided by g. Okay, so first of all, g is the picky eater. So we always take the g function's preference. But now there's something else that's also bad that happened. What number do we also have to exclude in this new combined function? -1, because now -1's in the denominator, so we cannot include -1. So the whole idea is first you check the two domain. You take the one that's pickier. Then when you put them together, you gotta double check. Is there another thing you have to exclude? Okay, next one, g times g. G times g is going to be x plus 1. X plus 1. So now what is the domain? All real numbers? Oh, no. It's still -1 to infinity. The reason being, you started with that. I am a low-calorie eater. No matter what, I'm going to stay a low-calorie eater. I will not change. Okay, so there's nothing you can do to change g. Okay, so if it has a very small domain, it will remain that no matter what. It cannot have more than it started with. Okay? Yes?
Do you always not include the denominator?
Yeah.
Okay.
Because it's going to make it 0. All right, so the whole idea is you got to check the domain. Okay, I'm writing this 2 times. Okay, check the domain of f of x, check the domain of g of x, and then check the combined domain. Okay, pick the picky eater. Okay, let's look at an example. So this is where you have to remember your parent functions pretty well. F is e to the x, g of x is square root x squared minus 1. Okay, we got to find the domain for all of these. Okay, what's the domain for e to the x? All real numbers. Okay, domain for g, you got to do this like on a warm-up. Okay, inside the square root has to be greater than or equal to 0, so try to find that. It's not the same idea. I mean, it's not the exact same number. This parabola x squared minus 1 is going to go up instead. a lot of you are still not doing this part right, which is not good. Okay, this is like that. When it's greater than or equal to 0, first of all, this parabola is going to go up. So this is going to be -1, this is 1. Where is it greater than or equal to 0? That's these two sides. So -infinity to -1, 1 to infinity. All right, which one is the picky domain, picky function? G is. So then let's go ahead and have you try all of them. So f times g, f divided by g, g divided by f. What are the domains? Okay, the next one, f times g. Nothing changed on my domain. Oops. F divided by g, so that is e to the x divided by square root of x squared minus 1, which means 1 and -1 is no longer in the domain. Okay, and the last one, g divided by f. Well, oops. E to the x can never be 0, so it's impossible to be 0 in the denominator, so that means we stick with the original domain. Okay, next one. I think I forgot to change the question, so let me change it. So let's say f of x is 2x minus 1. G of x is x squared plus x minus 2. Okay, go ahead and figure out the domain. Let me know when you're done. All right. F is all real numbers. G is also all real numbers. A lot of you are factoring and then you're excluding 1 and 2 or -1 and 1 and -2, but it is just a parabola. So it is just a transformed parabola. When you multiply them together, you're still going to get all real numbers. When g is in the denominator, however, you have to exclude -2 and 1. So that is stop at -2, stop at 1, and then continue. When f is in the denominator, now you have to skip 1/2. So skip 1/2, like that. All right. If you have any questions at all, again, please come to me, ask right away.